This is part 4 of section 6.2. From a point on a level plane at the foot of a mountain, a surveyor finds the angle of elevation of the peak of the mountain to be 20 degrees. So he's right here, and there is the elevation up to the top of the mountain. She walks 3,465 meters closer on a direct line between the first point and the base of the mountain. So from here, that's 3,465 meters. She finds that the new angle of elevation to be 23 degrees. Now estimate the height of the mountain to the nearest meter. Okay, so we were given this information, that 20-degree angle and that 23-degree angle. Because this angle and this angle make a straight angle, make a 180-degree angle, they are supplements. So angle B right there is 157. Okay, and then once you know 157 and 20, you can find that that tiny little angle up there is 3 degrees. H is the height of the mountain. Okay, so we have two triangles here. Well, actually 3. We have ABC, that little sliver there. We have CBD, which is this right triangle here. And we have CAD, which is another right triangle. Okay? What I'm going to do first is I'm going to concentrate on triangle ABC. So ABC, this tiny little sliver of a triangle. And what I want to find is A. And I know, what do I know? I know angle C, which is 3 degrees, that right there. And I know this side here, which is also C. If I'm looking for A, I'll do A over sine of angle A, which is 20 degrees, is equal to our C value over sine of this angle, which is 3 degrees. And you solve this for A, and your A value is approximately 22,644 meters. Okay, so I know the length of side A. Now, I can take either of my two right triangles and find the height. Let's look at the smaller one, triangle BCD. Okay, H would be side B of this triangle. So, and I'm looking for that. So H or B over sine of 23 degrees is equal to, well, you know what? I could do it that way, but we do have another option. Okay, I can just look at sine of 23 degrees since this is a right triangle. So we can ignore that if we want to. It will work, but we don't have to. Sine of 23 degrees is opposite over hypotenuse. Opposite is H, and the hypotenuse is A, which is 22,644. So your H value is 22,644 times sine of 23 degrees. And your height, rounded to the nearest meter, is approximately 8,848 meters tall. Okay, so now let's start talking about the ambiguous case, solving SSA triangles. So we've already seen some of these where we have no such triangle, there's one triangle, and there are exactly two triangles. And we haven't talked about why that might happen. Now we're going to consider the acute triangles and the obtuse triangles separately. If we look at our possible acute triangles, okay, where if we have an angle and then a side and a side, okay, it is possible that when we know this angle and the length of that side, there's no way that our A is long enough to hit this other side right here. So there's no way we can build the triangle out of that. Here, it is possible that our height, our A value, is exactly enough to make a right triangle. It's possible, okay? If your A value is the same as the altitude of the triangle. Here, it is possible that if we know our angle A and the length B and then A, it is possible that to make A long enough, we could either swing out to the right or we could swing it in and it would also work. So this is the case where we have two triangles. Okay, here we have an A value that brings it over here, and if we try to swing it around like we do here, it passes up our angle A. So this would only be one triangle. And then the same kind of thing happens when you have an obtuse triangle. It's just there's not as many possibilities. Either A hits this line here or it's too short. Okay, so let's work on solving this triangle, and we're gonna solve each one as much as possible. Okay, so here I have B, angle B, I have in two sides. So I do not know angle A. B is 40 degrees. C, I do not know. Length A is 18 meters. Length B, we do not know. And length C, we do not know. Oh, wait, no, we do know B. Sorry, 20 meters. Okay, so what do we have that we have in common? I have a B angle and I have the B side. So that's the one I'm going to be using most. And since the only other piece of information I have involves A, I'm going to try to find angle A first. So sine of A over 18 is equal to sine of 40 degrees over 20. So sine of A is 18 times sine of 40 degrees over 20. And so A would equal, or at least one possibility for A, would equal sine inverse of 18 sine of 40 degrees over 20. If you use this in your calculator, we're rounding to the nearest tenth, and you get that A is approximately 35.3 degrees. Okay, now the other possibility would be 180 minus 35.3, and that will give you 144.7. And then if you add the other angle that we know, we get something larger than 180, so that's not a good possibility here. We only have one triangle, and our A value would be 35.3 degrees. Now, since we have two angles, we find the third one by subtracting from 180. 180 minus 35.3 minus 40, and you get 104.7 degrees. And all we have left is to find our length C. C over sine of 104.7 degrees is equal to, I was given B, both B's, so I'm going with this one, 20 over sine of 40. And solve that for C, and you'll find that your C value is approximately 30.1 meters. Okay. So now let's do a triangle where A is 62 degrees, side A is 30 degrees, and side B is 40 degrees. So my A value is 62. I do not know B. I do not know C. Side B is 40, and I don't know side C. Okay, so since I have part of my B pair, I'm going to solve for angle B first. Sine of B over 40 is equal to sine of 62 over 30. Sine of B is 40 sine of 62 degrees over 30. So angle B, at least one of your possibilities for angle B would be sine inverse of 40 sine of 62 degrees over 30. And if you plug that into your calculator, you will get an error. And you will get an error because this part is greater than 1. And we cannot have sine inverse of a number greater than 1. So here, there is no such triangle.